Hi, I'm George Williams, founder and CEO of ReliabilityX. Today we're going to go through an infographic that helps us understand the bathtub curve as well as what maintenance is all about. So here we have the bathtub curve being comprised of all of the various failure patterns that exist. And so we've got things like our infant mortality section. And the infant mortality section is where things like electrical components, warranty issues, things where assets never really got into their run-in period. They failed prematurely. We then, all the way out on the far end, have wear out. This is where assets have lived at least through their useful life and begin to phase out based on age. Everything in between this is our random event time period. A vast majority of our assets fail at some point during this random event period, meaning they don't live their entire useful life and they didn't have a warranty issue. So let's take a look at how things happen. So when we design an asset, that asset ends up with some base condition. That base condition being how well it operates, what's its run rate, what's its typical built-in reliability. During the life of the asset, after it has passed this warranty period and it is now running smoothly, we have this pattern, this sawtooth pattern that occurs where we deteriorate and then restore to base condition. We deteriorate, restore to base condition. This happens over and over during the life of the asset. This is where we have to replace belts and our shivs are worn, and we have to align something and we eliminate some defect. And this happens over and over and over again. The cost of that reliability is the inverse of that sawtooth pattern. And so as we deteriorate, the cost to operate goes up. And as we restore to base condition, it comes back down. So we deteriorate and cost more. So for example, as our impeller wears, our energy use goes up. In order for the pump to operate within its parameters, we have to ramp up the VFD as the impeller wears, and so it costs us more. And then if we replace the impeller, we get back down to base operating cost. And so the opposite of the maintenance pattern is the cost of reliability. Now, this pattern is pretty uniform, and over again we do the same stuff. If we use techniques such as design for reliability and RCM, what happens is our base condition is improved. When our base condition is improved and we use techniques where we are identifying failure modes and the use of things like predictive technologies, what happens is we deteriorate at a lower rate when we design it better using design for reliability. And our costs are lower because we're using better techniques when we use stuff like RCM, an approach like RCM. So we deteriorate less over time, less often, have to take less interventions, and our cost base is lower. Now, eventually, we'll have some point of failure where, say, we contaminate a bearing. And so we've done all our restore to base conditions, but at some point somebody doesn't wipe off a grease gun and we end up with contamination in our bearing. This begins our PF interval, the point of potential failure until there is a catastrophic event. This is why we utilize technologies such as vibration analysis and ultrasound and IR and motion amplification and our senses, and why we inspect things. Once we hit this point, the imminent catastrophic failure is going to happen. We utilize predictive technologies to give us a window of opportunity in which we can properly plan, schedule, and execute the work before the major catastrophic event occurs. The reason we do this is to buy us time and to reduce the overall cost of the repair in terms of the operating cost and the just sheer other damage that could occur, right? If we don't use these technologies, what happens is the bearing blows apart, the shaft drops inside the pillow block, makes a nice oval, blows everything apart. Then we need a shaft and a pillow block and a bearing instead of just the bearing. And so we utilize these technologies to live in a proactive mechanism, or at least to give us enough time to properly plan and eliminate the catastrophic failure. Once we live within our senses, we are living within the reactive maintenance domain. And so once we are just using our senses, we don't typically have enough time to address the failure without the catastrophic event. Once the catastrophic event occurs, again, that cost goes way higher than it typically would be to restore to base condition. And so, as you can see, we utilize techniques like design for reliability and RCM and FMEA to get a much more robust maintenance strategy with lower costs and lower interventions, or at least less frequent interventions. We utilize predictive technologies to buy us a window of time so we're not living just in a reactive domain, and allow us to avoid the catastrophic event and the additional cost.